Okay, the last example video for tonight. Here we have number 7. Sine to the fourth x minus cosine to the fourth x divided by sine squared x minus cosine squared x. All of that equals 1. You can be sure if you want to type in that as a function into Desmos, you'll find out that it is just a flat line at y equals 1. So let's see what we're going to do with this. When I see minus signs in between two things that are squared, or to the fourth power, or to the sixth power, or the eighth power, or any even power, I tend to think difference of squares. So we have a lot of that difference of squares going on here for sure. So think about factoring, right? In fact, sometimes the other thing you'll see in this case, this is not this. The other thing you'll see that will trigger this idea is if you see 1 minus sine to the fourth x, or 1 minus cosine to the fourth x. This also is difference of squares. Remember, 1 is a perfect square, right? Perfect square. When you see perfect squares, including 1, don't forget that 1 is a perfect square. Think, oh, difference of squares. So I'm definitely going to work on the left side of this. The right side of this is already 1, so it's very simplified. We're going to leave the right side alone, work on the left side. And let's see, sine squared x minus cosine squared x times sine squared x plus cosine squared x. All over the same denominator that we had. Now you might fall into the trap of saying, oh, I have a difference of squares in the denominator too. Let me factor that as well. Well, what you might not notice in that case is that, oh, we can actually cancel. We can cancel from the numerator to the denominator this whole expression. Now, if you keep factoring, you will keep factoring both of those and then cancel what you factored, which is totally fine. So if we wind up doing this move, canceling those things, we wind up with just sine squared x plus cosine squared x over 1. And of course, sine squared x plus cosine squared x is 1. So that equals 1. And the other side equals 1. And we've demonstrated that this equation is in fact true. All right. So when you see these cosine squareds, sine squareds, think of Pythagorean identities. Notice the minus sign to start off with doesn't immediately give us an identity. We need sine squared plus cosine squared x. So factor, we want to factoring, right? So hopefully those examples give you some good foundation. What did we do? We used factoring skills. We did not go across the equal sign. We worked on one side at a time. We checked for Pythagorean identities, especially. We didn't use the conjugate yet, but we'll find some time to do that. We'll hit something in class, some example you'll wind up asking us about. Okay, hope that helps. And we'll see you in class tomorrow.